So good morning everyone. My name is Shravan Kumar from Delsoft Technologies, New Delhi. I'll be demonstrating today NetSim Network Simulator and its various features and functionalities. Now this tool allows user to design, analyze performance and validate its network, and also permit the user to edit the network protocols. Okay, so we go one by one through these slides and show you the features of this software. So why NetSim? So as you know, with the advancement of technology, newer protocols are being drafted very frequently, and it is very difficult to keep abreast with the latest happening. Moreover, analyzing network behavior using traditional analytic method has become very cumbersome. So it is not easy to manually analyze these network behavior. Considering the fact the large number of parameters are involved, we need these kind of tools for the accurate understanding of network behavior and the associated problems and their solutions. Okay. So now NetSim introduction. NetSim is a scientific tool for designing and validating networks and protocols. So it has a lot of relevance in protocol research and development, and in defense. For instance, it is used for simulating network-centric warfares. So it has wide range of technologies which is possible to simulate in NetSim are internetworks, which includes LAN, WAN, and wireless LAN, mobile ad hoc network that is MANET and WiMAX, and cellular network which consists GSM and CDMA, then cognitive radio, LTE network, then wireless sensor network which includes ZigBee. And this software has two versions. One is academic version and one is standard version. So in its academic version, we have the facility of designing all the networks and technologies in GUI mode, but in standard version we have the provision of using C source code and editing the existing protocol and creating our own protocol. Okay, so the purpose of this giving C source code is to enable users to edit the standard protocol according to their own requirement, and they can link it with NetSim and analyze the performance of their newly designed protocol. Okay. So now this NetSim has some customer segments, that is enterprise, defense, R&D labs, and academics. So in enterprises, it is used for network design and network validation. In defense, it is used for network-centric warfare. In R&D labs, it is used for protocol development and new technology testing. In academic, it is used for network lab, in BTech, in graduate level, and in MTech for Advanced Network Lab, and for PhD thesis and MTech projects. So it has some customer segment where it is being used. Now the architecture. This architecture will give you a holistic view of NetSim, where users will design the network and configure it in GUI interface, which will be further simulated by NetSim engine and thereby provide multiple metrics regarding the performance of the simulated network. So user is not required to write any script or code while designing and configuring the network scenario. So this is one of the most striking feature of NetSim, which is the NetSim engine itself. As you can see, it is utilizing a virtual network stack, which actually mimics the real world TCP/IP stack, and hence makes it very easy for user to edit any protocol and give the fairly accurate results. Now standards implemented. So this NetSim is divided into 9 components, and these components are designed on the as per the international standard, that is IEEE, RFC, IETF standards. So first component is Internetworks, that has Ethernet, LAN, wireless LAN on different IEEE standards 802.11 A, B, G, N, A, C, and E. Now, then propagation, then routing, firewalls, then queuing, and some common module applications are there, which has traffic generator, where you can generate various kind of traffic, that is voice, video, FTP, database, HTTP, email, peer-to-peer, custom. So these kind of traffic can be generated on any node from one source to destination. Then it has virtual network stack, simulation CLI, and matrix engine, which has packet and event trace, then packet animator. So these are some common module application which is available in component 1. Now component 2, legacy network, that is Aloha, pure Aloha, slotted Aloha, CSMA CD, token ring, token bus. Different legacy network you can simulate in component 2. Now component 3. Component 3 has BGP, border gateway protocol. Then component 4 is advanced wireless network, that is MANET, which includes DSR, AODV, OLSR, ZRP, and WiMAX protocol. Now component 5 has cellular network, which is GSM and CDMA. Now component 6. Component 6 is wireless sensor network and PAN, personal area network, which includes agent model and battery models, ZigBee. Then component 7 is cognitive radio network, that is wireless radio area network. And component 8 has LTE, long-term evolution, and component 9 has military radio network. So here you can see for component 6, component 4 is required. So if you want to use component 6 wireless sensor network, you have to have that MANET module, component 4. And component 9 is also having the component 4 required. That is a requirement for component 6 and 9. Now what's new in V8? So some of the features have been upgraded in this version, current version. That is LTE, OFDM for downlink, SCFDMA for uplink, and MIMO for enhanced throughput. So these are some of the features that is upgraded in LTE. Then in dynamic matrix, you can get the graph of application throughput, link throughput, and congestion algorithm. So these three graphs you can see in dynamic matrix. So that can be inserted while doing the simulation. You have to just select the dynamic matrix and click on put it after the simulation. Then UI property view. In this, you can customize various properties in any devices via XML file. So there are some existing properties given in the node, or you can edit some of those properties by going into the XML file. Now BGP and cellular, that is GSM and CDMA with stack, that has been upgraded. Now, and some of the new application model, that is peer-to-peer, email, and HTTP also have been upgraded. Now NetSim hands-on. NetSim hands-on is divided into two parts. The working of the whole NetSim software has been divided into two parts. That is, part 1 has model, simulate, and analyze a variety of network. And part 2 has write your own code and link it with NetSim. So in first part, you work in JOI, and you design the network, simulate the network, and analyze. And in second part, you have the custom code facility. You can go into the Visual Studio and edit the existing protocol and link it with NetSim. So we'll go one by one through part 1. Part 1 has design the network. In design the network, you are having all the nodes available in the software, right from the wired, wireless nodes, switches, routers, all the nodes available. You just have to drop down this into the environment, and you can link it with wired or wireless nodes and design the network. Then configure the network. And for configuring the network, you have to right click on the properties of the nodes. You can edit those properties. So some of the properties are set the default values, and some of properties are variable, so you have to change those parameters according to your requirement. And you can save those files and run the simulation. Then model traffic. Model traffic is, as I've told you, you can generate various kind of traffic on any node. So you just have to drop down the application tab and select the application type, whether it is custom type, peer-to-peer, email, HTTP, various kind of traffic that has been given in the application. Then you have to select the source and destination and give the values, arrival time, packet value, all these you have to set. After the modeling the traffic, you have to simulate. In simulation, you have to give the timing of the simulation, whatever time you want to run the simulation, and you have some option for setting the recording and running of the animation. So that has to be set while doing simulation. Now, summary of this first part, that has modeling and simulation. You can see in the screenshot some of the notes on the links have been created, and here application tab has been dropped down, and you can see application type, that is CBR, custom, email, HTTP, this kind of application type is there. Then source and destination ID you have to set, and packet size and inter-arrival time has to be set. When you set this parameter, you can go to the simulation run. Then you can run the simulation through a command line interface or XML based config file. So when we create any GUI file of any program, that file will be saved in XML based config file. So we usually prefer XML based config file because it is very quicker for understanding and better presentation. It has automatically format verification. So these two screenshot will show you this is in the XML mode and this is in CLI mode. Now analysis. In analysis, when you run the simulation, it will give you a performance matrix. This performance matrix has several matrices given related to network, then links, devices, protocols. All these have been given in performance matrix. Okay. Then packet animator. The packet animator will give you the flow of the packets moving from one node to another. You can set those animation by reducing and increasing their speed. You can see packet animation faster. Then analysis summary. So as I've told you, performance metrics have several metrics. That is network metrics, application, link, protocol, and device metrics. So different metrics have different scenario. Like network metrics allows user to view the values of metrics obtained based on the overall network. It gives you the idea, the whatever being simulated in the network, that will be shown, the overall result and overall throughput. Then application metrics. Application metrics displays the various metrics based on the application running in the network scenario, like throughput, delay, and etc. Okay. Then link metrics. Link metrics displays the values of the metrics related to each link, like packet transmitted, packet errored, packet collided. Okay. Then protocol metrics. Protocol metrics displays the protocol-based metrics which are implemented in network scenario. And device metrics give you the device-related metrics like ARP table, IP forwarding table. So different metrics have relevant to those metrics. Now packet animator. You can see in the screenshot some packets are moving from one node to another. Simulation time is running. You can increase and decrease the animation speed from here. So this is for better presentation of the packets. You can change the color variation of control packet, data packet, and error packets. Now, as I've told you, some of this the software has two versions. One is academic and one is standard. So whatever feature I've told you, these are available in both the versions, in academic and standard. Now, some of the feature which is exclusively available in standard version are traces. Traces have two types. One is packet trace and one is event trace. Okay. So this packet trace, it gives you a set of chosen parameter for every packet as it flows through the network. such as arrival times, queuing times, departure time, payload, overhead, errors, and collisions. As you see in the screenshot, blue one is the packet trace, and this black one is the event trace. So these are the attributes that is given in packet trace, and this packet have been created here. So it is very useful for performance validation, statistical analysis, and custom code debugging. And this event trace, it records every single event along with its associated information such as timestamp, event ID, device ID, protocol name, everything about the events. It's recorded into the event trace. It has to be enabled during the simulation. Now dynamic metrics. Dynamic metrics allows user to monitor the value of a parameter over simulation timing. So it will give you a graph of link and application throughput that can be plotted during the simulation or after the simulation also. We usually prefer offline, that is after the simulation, because during the simulation it affects your simulation timing and it will slow down your simulation. Now Wireshark. Wireshark, as you know, is a free and open source packet analyzer which is used for network troubleshooting, analysis, and communication protocol development. So in NetSim, instead of performing some mathematical calculation and providing the result to the user, it actually generates the packet and transmit it within the simulated network. Hence, Wireshark can be used inside NetSim to capture these packets at multiple node location and perform further analysis. So it will give you the real-time packet capturing, as you can see in the screenshot. Some TCP packet have been created here, and some graphs have been generated, that is RTT graph and window scaling graph. Okay, so the Wireshark can be enabled from the nodes parameters, where you can give it online or offline. If you select online, the Wireshark would be enabled and it will run during the simulation. Now part 2, development platform, that is available in standard version only. So you can see in the screenshot, first screenshot is of programming, that is in the Visual Studio environment, and this is the NetSim environment where GUI has been created. So some of the statement have been updated in GUI, the programming, printf command of hello world. So when we build this file and link it with NetSim GUI, and when you run the simulation, first it will print hello world, then it will go to the simulation. So that is to show you how we can change into the protocols, existing protocols. The source code are available in NetSim installation directory, that is C program files and NetSim standard. And the NetSim also provides some of the APIs for protocol developer, which is helpful in protocol development. That is protocol packet.h, tag.h, list.h, NetSim graph.h, IP addressing.h, and these are the APIs which is available for protocol development. Now NetSim has 300 plus customer base across 15 countries in different domains like defense, space, industries, and education in international and India. Now we will go to the software and show you how we can work on this. So it is a software environment. So for designing any network, you have to go for NetSim simulation, new, Internetworks, legacy network, advanced wireless network, BGP network, cellular network, wireless sensor, personal area network, cognitive radio, and LTE. So legacy network has pure aloha, slotted aloha, traditional Ethernet, token bus, token ring, different legacy networks. Advanced wireless network has MANET and WiMAX. Then BGP cellular network has GSM and CDMA. Then personal area network has ZigBee. So different network have been given here, and some of the programming exercises given here for different protocols like ARP, cryptography, DVR, ERC, different programs have been given. There is utility for log in as an administrator and you can create some of the user in between. This is help manual for NetSim user manual, source code help, and experimental manual. So some of the experiment have been given in the manual. You can design those experiment step by step and see the result. Now we'll go in the simulation and see in Internetworks. In Internetworks, we can design wired and wireless network both. So here you can see some of the nodes are enabled and some of nodes are disabled. So this you can see base station, wireless sensor network. These are not related to Internetworks. So these are being disabled. And some of the nodes are also disabled here. Only wired and wireless node enabled. So you have to just click on this wired node and you can place it into the environment. Okay. You have to put some switches, one router, and if you want to connect some wireless node, you have to connect access point and one wireless node. Now for connection, you have to click on link. First of all, wired link to connecting this wired node. Then for wireless node, you have to select wireless link. So your network is completed now. You have to select the parameters of these nodes. So you can right click on any node and go for properties. In properties, you can see some global properties have been given. It is device name, device type, its position, Wireshark, interface count. So as I've told you, we can enable Wireshark from here. If we select the online, it will capture the real-time packet during the simulation. So we'll select the online just to show you the Wireshark feature. Then in transport layer, TCP and UDP protocol has been given. It's the features of MSS, congestion control algorithm you can change, window size, in segment size you can change in UDP. And there are some information tabs given here. So if anyone doesn't know about these features, you can select the I tab, information tab, and see the definition of these properties like congestion control algorithm. So why it is being used and their information is given in this information tab. So for every I tab, there has the information of those parameters. So now in network layer, IPv4 is there. You can change some of the parameters. In interface of Ethernet, there is network layer, data link layer, and physical layer. In network layer, you can change the IP addresses, subnet mask, default gateway, then the retry limit, retry interval. So you can select it. Like the nodes, you can select the link properties. It has the link type, link medium, link mode. It's uplink and downlink speed, uplink BR, downlink BR. So you can implement some errors or you can select no error. You can choose the switch property. So it has the three interface. So 1, 2, and 3 Ethernet interface has been given. So you can select the switches property and change from here. Switching mode is store forward, cut through, or fragment free. You can choose any one. Speed you can define, and buffer size, switch priority. All these parameters you can set from here. So these are some other interface. Then in router, transport layer, network layer. In network layer, you can set the firewall status. If it is true, it will block some of the nodes from sending the packets. Then interface of Ethernet, you can change IP addresses in network layer. Then scheduling type, buffer size, retry interval, retry limit, data link layer, physical layer. Okay. Then interface 2, same feature, you can change. Then in access point, it has the interface of Ethernet and wireless both. So in wireless, we have the features of wireless and data link layer and physical layer. In data link layer, you can define these IEEE standards, buffer sizing, retry limit, RTS threshold. You can define the standards, the transmitting power, standard channels you can define. So these are some of the default parameters and some are variable parameters. You can click on accept and you can select the wireless link also, the link type, link medium, link mode, channel characteristic you can change. There is fading and shadowing, fading only, line of sight. You can select no path loss, accept, and this is for wireless node. So some of features are different for wireless node. Okay, so we can set it default. Now we have to send some traffic from one node to another. So we just have to drop down this application tab here and right click properties. So in application 1, you can see application type. When you drop down, you can see custom email, HTTP, video, voice, database, FTTP, various kind of application type is given here. You can select anyone like custom type of packet and you have to select the source and destination. Let's say source ID 1 to source ID destination ID 6. 1 to 6 we are sending a custom type of packet and it has packets distribution as exponential. Value we can set default. Inter arrival time we can change to exponential or constant, and value of the timing for inter arrival. So you can accept it, or if you want to add some more application you can add from here and you can set various custom type and source and ID different. So you just have to accept it. Here you can see one line that is custom type of application has been set for 1 to 6, and now some of the feature that is available in standard version, that is packet trace, event trace and dynamic metrics. So you have to select packet trace and give the name of packet trace. File type is .csv, that is in Excel format. This is a storage path and these are the attributes that would be available after the simulation. These are common attributes. This TCP, wireless LAN. So you have to select OK. Now in event trace you have to give the event trace name, and these are the attributes. It's for ARP, fast Ethernet, RIP, TCP, wireless LAN, OSPF. So these are the default attributes given here. Just click on OK. Now dynamic metrics. If you want to enable dynamic metrics, you just have to select plot graph after simulation, link matrix, congestion window, application metrics. So just have to click on OK. It would be selected. Now we will run the simulation. Here we can select simulation timing, so 30 seconds, and you can set packet animation for if you want to record animation, play and record both, or you don't want to play and record animation. So we want to see the animation, so we'll select first one and click on OK. And as we have selected Wireshark at the node 1, so it will start during the simulation only and capture the real-time packets. That is started now. आवाज नहीं आ रही है देखना क्या तुम्हारा अरे मेरे में दिखा रहा है आवाज नहीं आ रही है कनेक्शन आई थिंक लॉस दिखा रहा है मेरा ये संजीता मैम को ऑडियो नहीं आ रहा था बात किए थे हेलो हेलो क्या? हाँ क्या हुआ? हाँ हाँ हाँ। हेलो Sujit sir, are you getting my voice? Hello. Hello. Okay. Okay. Hello. Are you getting my voice? Hmm? क्या तुम हो तो? Checking. Hmm? Hello. Hello. सुरजीत सर, आर यू गेटिंग माई वॉइस? यहाँ आ रही है? वो तो सुबह बोला था. हेलो. 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 आर यू ऑल गेटिंग माई वॉइस? हेलो. Hello, Surjit sir, are you getting my voice? Please reply. Actually, I'm not getting any reply from actually. Hello?
Some call drops are present.
Yes, sir.
Some voice is not proper.
Yeah, I think there is a network problem.
Yeah.
You are not getting my voice properly?
Yeah. I am not getting voice properly.
Okay, okay. Actually, there are some network problem, I think.
Yeah. Okay. 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 Now I am getting some clear voice.
Okay, okay, sir. Okay, then I continue.
Okay. Okay.
Okay, okay, okay. Okay, ma'am. So now we have simulated this network. Wireshark has completed the capturing of the packets. We'll see this later. First, go to the performance metric that has been created after the simulation. So in network metrics, as you know, I've told you that performance metrics has some of the divided network metrics, link metrics, application metrics, device metrics. So the network metric has the overall throughput of network, that is simulation timing, packet transmitted, packet errored, collided, bytes transmitted, payload transmitted, and overhead transmitted. So the overall result of the network is given in network metrics. Then in link metrics, you have the information of the link. It is link ID 12345. According to the link, you have packet transmitted, error packets, collided packets, then bytes transmitted, payload transmitted, and overhead transmitted. So your overall throughput would be given in application metrics. That is, you have generated the packets from source ID 1 to destination ID 6, which has packet transmitted, this one, packet received, duplicate packet received, payload transmitted. Throughput, that is the overall throughput of the network, and delay. Okay. Now we have set the dynamic metrics. So under the dynamic metrics, you can see the link throughput for link 1, link 2, link 3, link 4, and link 5 of the wireless. So these are available in dynamic metrics only. In application throughput, I have custom type of throughput. That is 0.60 is the mean value of this throughput. Now TCP congestion window. You can see congestion window graph. Now we'll see the packet animation. In packet animation, when you play the animator, it will show you the packet animation. First it will send signals, then when it acknowledges from the destination, it will send custom type of packet. You can see this green line is the custom type of packet moving from 1 to 6 via source and router and access point. So you can increase or decrease the packet animation from here. You can decrease the animation where the just seeing one by one packet moving. Okay, now you can stop this simulation and go back to further analysis. Now we have set also packet trace and event trace. So in packet trace, when you open it, it will open that file that we have saved. It will open in Excel format. Here you can see the packets, all the detail about packets, like packet type, control packet, source, destination, transmitter, receiver, all the information of packets. So if you want to see one by one packet movement, you just have to do some changes in Excel file. Just select this. You can freeze those panes, top row, and select for filtering. So now if you go into the packet, select packet number 1. So you see packets number 1 have moved 4 times from node 1 to node 6, node 1, switch 3. This is the path where your packet 1 has moved. It's all the detail, transmitter, receiver, whether it is successful or not. Okay, local foreign IP addresses, all the information about your packets, its size. Okay, so you can see one by one packet analysis from here. You can select more than one packet, like 3, 5. So you can select those packets one by one and analyze. So like packet trace, you can select event trace from here. Same event trace file would be open in Excel. So this event trace has the information of events performing in the network. The same thing you can done to see the better view of this event trace. And you can select event by event and see the result. This is event 9. You can select more than one event. So it's event type, event timing, device, interface, packet, application. All these you can see from event trace. Okay. So now we have to save this file and go for network NetSim analytics. It is another feature of NetSim which compare various matrices among these parameters. So in there are various network given. If you select Internetworks, you can browse the matrix file of various experiments created. So you have to select more than 2 or 3 matrices. So now you can see there are 4 matrices. So that can be compared according to simulation timing, packet transmitted, packet errored, packet collided, bytes transmitted, payload transmitted, and overhead transmitted. So it has been simulate by having various different parameters. So they are having different result. So we can compare between these matrices under one technology. Okay. So likewise, you can compare various matrices in different networks. Now we have seen GUI functionality in NetSim. Now we will see how we can change something in the protocol, existing protocol in Visual Studio. So we have to go into the installation directory of NetSim, that is C program files and NetSim standard. So in this NetSim standard folder, it has a bin folder. In bin, there are all the protocols that are existing in the NetSim have been given in DLL format. So the NetSim accepts the DLL format only. So if you want to change anything into the protocol, you have to save the file, build it into the DLL extension only. And if you want to create any new protocol, you have to select the DLL extension only and link it with NetSim. Okay. So for editing any protocol, you have to go to src folder and in simulation. So we have created a copy of this simulation folder just to save our existing protocols, so that our real protocol DLL file would not affect. So there is a NetSim extension. This one is a NetSim link for Visual Studio. If you click on this link, the Visual Studio will open. That I've already opened it. So here all the protocols that is given in the NetSim are listed. Okay, ARP, ATM, cellular, cognitive radio, DSR, Ethernet, LTE, all this protocol. So if you open one of the protocol like DSR, DSR.c file has to be open. So in DSR.c we have make some changes. So here you can see in this DSR.c file, this is a program, and we have inserted one hello world printf command where it will print a hello world before simulating our network. Okay, so this command has been set and we have to just build it. dsr.c, so right click and build. I've already made it to save the time. So if you click on build, it will create a DLL file that would be saved in the same simulation folder and DLL. So that DLL has libdsr.dll. This file would be saved here, and you just have to copy it and paste it into the bin folder. I've already copied it. It is libdsr.dll. This is our edited DLL, and this is our libdsr default DLL. We have renamed it just to save our original DLL function. So when we call this DSR function, it will call our edited dsr.dll. So I'll just show you how we can call this DSR function. So in NetSim, we have to select one program for calling the DSR function. Let's say MANET. We can open one of the MANET functionality. So in MANET, we have selected 5 nodes, and we have selected one CBR type of packet application from 1 to 5. So we just have to run the simulation and give the simulation timing in 50 seconds. Click on OK. So when we run the simulation, it will first print our hello world command, then it will go to the simulation when we put enter. So here you can see in the CLI command window, hello world is printed. Okay, so when we enter it, it will run the simulation. This result would come, all the parameters. You want to see packet animation, click. So that is just to show you how we can edit the protocols in Visual Studio and link it the DLL with the NetSim. Okay. After this, we can see some of the programming exercises that is given, like ARP, cryptography, DVR. Let's say in cryptography, we select substitution, and there are sample programs given here. Like for encryption, if you select one plain text and give that key text and run the simulation, it will run according to the sample programming given in the backend. So it will give you a ciphertext according to the key value. Okay. Now for decryption, you have to run, and it will give you again the plain text. If you want to see this sample programming, you have to click on interface source code, and that program will open in Visual Studio. If you click on interface source code, this sample programming will open in this Visual Studio. You can see this programming. This is in Visual Studio with the same encryption. Okay, you can edit any functionality in this programming, and if you want to create your own program, you can save it in Visual Studio and link it with NetSim. For linking those exe file, you have to click on user. It will ask you the exe or jar file. You can select the file from here, and you can run the program according to your protocol. Okay, and its concept, algorithm, pseudocode, and flowchart can be seen from here, just for study purpose. Okay. So, like cryptography, you can see any one of this. You can see some of the features of Wireshark also, as we have captured some of the TCP packets. You can see some of the graphs like in conversation. If you go into TCP, graph A to B, you can see RTT graph, throughput, time sequence, window scaling. Various graph can be seen from here. Then IO graph can be seen. If you select TCP, IP, let's say ICMP, and select these graphs. If you select time interval, you can see the graphs from here. Okay, so these are some of the features of Wireshark. You can explore more into this, and I've done with my presentation now. If you have any query about NetSim or any other queries, you can ask me. If you don't have mic facility, you can write your query into the text box. Hello? मैं unmute है सर. Hello? Could you all hear me? आवाज नहीं आ रही क्या? Hello? Ankita ma'am, can you hear me? Any other queries? Hmm? Yes. Okay, any other queries? Hmm? Hello? Yeah, Vash. Hmm? ऑप्शन नहीं आ रहा है बनाने में. Hmm. Do you have any other queries? If you have any query, you can mail me on my email ID, or you can call me on this number. Okay, thank you all.